All right, explorers, welcome along. It's time to get creative and to get curious. We're searching out all the science secrets in the Fun Kids Science Weekly. My name is Dan. Welcome along. Every week, you and me, we travel all over the place, finding some of that science that no one's discovered before. This week, we'll chat to food scientist Maryn McKenna all about how climate change will affect what you eat for dinner.
People who work in crop science and farmers and so forth are terminal optimists. They have to be, right? And what they say at this point is that this is a big world. And there's a lot of growing areas in the world that we're not fully exploiting. So it's not necessarily that we're all going to starve, but we might have to get used to food crops coming from different places than they come from now.
And our gadget genius, Techno Mom, is back, looking at how brilliant inventions are made and how they help you every day. And today we're making things brighter.
LEDs are another type of lighting, made from tiny bulbs that are lined up in grids. You can see these on some torches, cycle lights, and even on some street and traffic lights, and in people's lights at home. Each LED is made to produce one colour of light when electricity passes through it. They use even less energy than CFLs and can last over 10 years.
And this week, our Dangerous Dan looks at a tiny deadly creature with rough skin that oozes poison. It's all on the way in a brand new Fun Kids Science Weekly. Let's start things off with your science in the news. And scientists have discovered a gigantic ring-shaped structure in space, which has changed everything they thought we knew about the universe. It is 1.3 billion light years across. It's named the Big Ring by astronomers. It's made up of galaxies and galaxy clusters. You need a telescope to see it because it's so far away, and even that can't see it in one. This has actually been found by different telescope pictures with computers joining it all together. It takes a lot of computing power, and it's changed everything we thought we knew about the universe, science, and the way it works, because our idea was that all matter was spread smoothly across the universe. But this ring looks to have some order to it. Like these galaxies are linked across billions of light years. That completely changes how we thought the universe works. And this is a huge deal. Imagine if we've discovered this now, what we might discover in the future, and how strange that things might be, and how wrong we could have been in the past. That's what's brilliant about science. Also, talking about discoveries, a huge ancient city has been found in the Amazon rainforests, hidden for thousands of years by vegetation. And this discovery changes what we know about the history of people living in the Amazon. Houses and town squares were found in the country of Ecuador, all linked by roads and canals. It lies in the shadow of a volcano. That would have made really rich soils, filled with nutrients that could grow plants, but also the volcano might have led to the destruction of the city. Experts say that it's older than any other site we know in the Amazon, and we really only thought people who lived there were in small communities, not something this big. Again, it goes back to what we were saying. We are constantly discovering new things about how we were and what's happening in the future, and it completely changes everything we thought we know. Science is a constant journey of discovery. We're always asking questions. And finally, looking back to the past, a dark sliver of rock pulled from a limestone quarry in the United States has found the world's oldest bit of skin. The fossil is nearly 290 million years old, and the skin would have once been on the amniotes, who were four-legged vertebrates that evolved from amphibians. They were the early reptiles, birds, and mammals. They were the creatures that first went from swimming in the sea to walking on land, and this skin is the oldest evidence we have of them, which is helping scientists understand more of how creatures made that massive step. Let's check in with Benny and Mal then. These are our microbe friends who are constantly taking a look inside your body, how it works, what all your organs do. And they've been dealing with big questions, ethical dilemmas, where there is a right and a wrong to the answer. This week, they're looking at what it would be like if we replaced body parts. maybe you could live forever. But what would be left of the original person? Would we end up as a robot? And who would be responsible for fixing us?
Benny and Mal's Body Teasers, with supports from the Nuffield Council on bioethics.
Ah, hello again. Sorry about the ruckus. My friends Benny and Mal, microbes that live at the bottom of an old test tube, are single-celled organisms that are very single-minded. Just have a listen. Benny and Mal never agree on anything.
No, I am listening. You're the one that's not listening.
So, lads, what's the hot topic today? Oi, lads, what's the hot topic?
Sorry, mate. Taking me forever to get a word in. And today's heated debate is all about living forever.
Or trying to. I mean, come on, we'd all love to live forever, wouldn't we?
I wouldn't. Don't you think it would get a bit boring? After, the 500th birthday, you might actually get tired of opening presents.
Unlikely. Well, human beings seem to try very hard to stay alive as long as possible, don't they? They take medicines, replace broken hips and knees, use wooden legs, and have pacemakers to keep their hearts ticking.
It's a good point, although I think prosthetic limbs are plastic, not wooden. But that's not really trying to live forever, is it? It's just fixing broken bits.
But what if you could fix all the broken bits for years and years and years?
Well, I suppose. Yeah, well, you'd live forever then. Unless, I don't know, you were exploded in the vacuum of space.
Exploded in the vacuum? What planet are you on?
Well, none, mate, if I'm in a vacuum. OK, bad example. I just wouldn't like the idea of all that metal and plastic clanking about inside me. It seems like the more stuff you need, the more you have to trust it to keep working. I mean, even tablet computers go on the blink at times.
Well, humans have to trust their bodies all the time. You don't see them sitting around saying, "Please keep beating, Mr. Heart. Ooh, don't stop swishing, little blood cell dudes."
I take your point. Perhaps you'd forget about all the implanted bits and bobs. But what if you had loads of stuff replaced and one day you woke up and it freaked you out being some kind of robot cyborg human? What would you say then?
Ungrateful. That's what I'd say. Ungrateful robo-human.
Yeah, and if all of me was replaced, is there a point where I wouldn't actually be human anymore? And what if I don't like being a robot anymore? What if I'm bored of living forever? Take it out! It's up to you what you put in your body, isn't it? Whose body is it anyway? Take it out!
Well, it might be your body, but if you want to go back to the way you were, then someone has to take it all out, unless you fancy doing the surgery on yourself.
No, mate, definitely not. That is not the direction I'd want to go in. But you've shown another little problem there. We have to rely on others to put this stuff in and out. What if it goes wrong and it needs fixing?
Malfunction.
Do you have to pay for the repairs?
So what if you have to pay for repairs? If you've got the cash, you could even get some super enhancements.
But what if you're poor? Are you saying only rich people get the choice of living forever? That doesn't sound fair to me.
Life isn't fair, mate.
Lazy thinking there. If you ask me, we should be thinking about how we can best use the science and technology at our disposal to make things fair.
It's a brain-busting body bamboozler for sure.
Sure is. Catch you next time.
Benny and Mal's Body Teasers, with supports from the Nuffield Council on bioethics. Find out more at funkidslive.com/Benny and Mal.
Let's get to your questions then. I love this part of the show where you send over anything sciencey that you've been wondering as a voice note to the free Fun Kids app. You can also find it and record yourself on the Science Weekly page at funkidslive.com. Our good friend and star of this week's show, Jake, has done that.
I just want to know, if energy can't be created, where did it come from?
Now, energy, Jake, is really tough to get your head around. And energy can't be created or destroyed. It's only converted. It's moved from one form of energy to another. And that is a fundamental idea of science. It's known as the conservation of energy. Now, the general belief is that all energy came about from the Big Bang billions of years ago, that huge burst which flung matter across the universe. And all the energy we have comes from that, we use it, and it ends up going back into the universe. The main source for energy here on Earth comes from the sun. Solar energy, which comes from nuclear fusion on the sun, converts one form of energy to another. That solar energy helps the plants grow and stay alive. The plants are then consumed by animals. You might eat plants, you might eat animals too. So you've got that energy now. That changes to kinetic movement energy in you, which then goes on and on and on. It's like a flow chart. Have you done those in school? One thing becomes another thing, which helps another thing. So that energy isn't created. It's just constantly changing form. And that is how energy isn't made, but it's always there. Jake, thank you very much for the question. This has been sent over to me from Rowan in Scotland, who wants to know, what do viruses eat? Well, viruses that can infect your body work like being a parasite. It's a brilliant question because you have to wonder what keeps viruses alive in your body. And by starving them of that, it's one way that you defeat the virus. When you get infected by one, it goes straight for your cells and it feeds off those cells. You make something called ATP, adenosine triphosphate. It's a compound in your cells that gives them energy to grow and to move, and it also feeds the virus. So as you get infected, the virus will stick to your cells. It'll become like a vampire bat, like a leech, a parasite, a mosquito that sucks all that ATP, that uses that energy to help them out too. And that is how viruses stay alive, Rowan. Thank you so much for the question. If you have anything you want answered next week on the show, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. It's the Fun Kids Science Weekly. Now, we talk a lot about the climate crisis on the show and how it impacts your life, but what will it impact on your plate? What about what you eat for dinner? Let's find out. Maryn McKenna is a science author and has done a lot of digging in this. And Maryn, thank you so much for joining us. So let's just start off. There is so much to be thoughtful and perhaps concerned with the changing climate. What made you really interested in how it might impact food in the future?
So, like any journalist, I read what other journalists are writing over the year, right? In other newspapers and magazines and so forth, and on blogs and things on the web. And over the course of the year, I just kept seeing all these stories about how many crops were suffering this year. Potatoes and tomatoes and corn and barley and olives and oranges. There was story after story about how strange weather patterns were affecting the production of all these crops. And when you look into what the reason is, it's all that the changing weather patterns have something to do with climate change.
So, at a very basic level, how is it affecting it? Because, you know, summers are hotter and we're told that winters will be colder, we'll get more rain, we'll get a lot more of the extremes. Why will that affect how our oranges grow, how many olives we can eat? Very simple stuff like that.
So every crop that we eat is grown in a place that's best for it, right? Like olives are grown in Spain. Spain makes more olive oil than anywhere else in the world because the warm, dry conditions on the slopes where those trees are best for that particular plant. That's the same reason why we grow corn in particular parts of the United States or oranges in Florida and California. But the things that those crops need to grow the best are moving away from where the crops are. The oranges might be in a place that's getting drier or hotter or is getting much more rain than the crop can really sustain. So the weather that the crops adapted to is now leaving them and leaving the crops behind.
So what can we do about this in the future without being too drastic and all having to individually change every single part of what we do and what we eat? What generally, how can this be fixed moving forward, or is it too late and oranges will never be the same again?
There's really only two things you can do broadly. One is you can move the crop to where the weather's good now. And the second is you can change the crop. But neither of those are things that can happen really quickly because we're talking about really big industries. So maybe if you're someone who grows grapes to make wine, you might change the kind of grapes that you grow and make a different kind of wine. Or you might move the coffee plants further up a mountain where it's cooler and the kind of temperature that the coffee used to grow in. But That's a big production, moving that kind of crop production around. The other thing is that we could rebreed crops, whether they do it the traditional way that farmers have always done it, or they do it in the laboratory with something like CRISPR. But you still have to take those tinkered with crops and test them out in the field. And that takes a couple of years to figure out whether the crop that you've tinkered with really works as well as you thought it would.
Now, for the last few years, I know I have, and many people listening might have really cut down on how much meat that we're eating, because we're told that meat agriculture, emissions mainly from cattle and beef, is very harmful to our atmosphere, and that's impacting the climate, right? So we're eating a lot of vegetables. Well, the problem is there going to be any vegetables left for us to eat? Will there be a time, Maryn, when there is nothing grown that we can possibly eat?
People who work in crop science and farmers and so forth are terminal optimists. They have to be, right? Because even if the climate weren't changing, there's always something that's happening on a farm that's going to be depressing. And so you just have to have a good attitude about it. And what they say at this point is that this is a big world. And there's a lot of growing areas in the world that we're not fully exploiting. So it's not necessarily that we're all going to starve, but we might have to get used to food crops coming from different places than they come from now.
So let's time travel a second, Maryn. Let's throw ourselves 20 years into the future, 30 years. I'm sitting down in my, no doubt, mega mansion because I've earned loads of money. My dining table looks out over my massive swimming pool. I'm up in the hills. The sun is shining. I know. I've got all my awards for various podcasts and films that I've starred in.
I'm very impressed.
Well, thank you very much. You're more than welcome to come over. But what are we eating? What's on our dinner plate in 20, 30 years, Maryn?
So for one thing, it might not be beef. It might be chicken, because it turns out that chicken is actually much less harmful to the climate than beef is. So maybe we give up on cutting down the Amazon and we turn around to growing much more chicken. So there's chicken. We might not be drinking the kind of wine that people are used to drinking. And we might not even be drinking beer, because barley is one of those crops that's being affected by where the climate is changing. But we might still be able to eat things like salad and tomatoes and spinach and things like that if we can figure out how to grow them in a more protected way, like in glass houses, for instance, that doesn't use a lot more energy, because energy is going to get more expensive.
Last question, and it's really for you to calm me down. I'm a vegetarian, and I think I might be the only vegetarian that put on loads more weight because I substituted meat for just like pasta. Just loads of pasta. So please tell me that in 30 years, with all my tomatoes, I can have some spaghetti. Like, spaghetti's not going away, is it?
I don't think that spaghetti's going away, because spaghetti's a wheat crop, right? So in the United States, wheat production is moving north. It's moving out of the parts of the country where we had those historic amber waves of grain that's in one of our national anthems. And it's moving toward more colder climates and up into Canada. So we'll still have wheat, but I'm not sure if you're going to be able to have olive oil on your spaghetti. And I might even be a little skeptical of tomatoes. So you might have to find some other sauce to put on it instead.
Okay. A lot of dry spaghetti for us. Listen, Maryn McKenna, thank you so much for joining us.
You are welcome.
It's the part of the show where we explore the universe and strange parts of our planet to hunt out the weirdest, the strangest, the most deadly things in the world. It's called Dangerous Dan. This week we are headed to North America to take a look at the rough-skinned newt. So can you guess what animal it is? What makes it unique? And what its skin's like? That's right, it's a newt, and it's got rough skin. A newt is an amphibian, but it looks a bit like a lizard. They have 4 legs, a long tail, a thick head at the top. The rough-skinned newt is quite stocky, with a much more rounded head than others. It's normally brown or dark green with a bright orange underbelly, and they grow to just under 20 centimetres, so not too long. Their skin is rough, bumpy and bobbly, and it makes something very strange. They sweat a toxin, poison, to defend themselves from predators. Now, they do warn you about this. If they feel threatened, they make a disgusting, vile stench. They don't fart it or anything. It kind of radiates from their body. which lets other creatures know to stay away. But if they carry on, they will sweat out this poison called toxin. You might remember one of the first dangerous stands that we ever did was all about the pufferfish. It's a fish that expands itself, that puffs itself out, and that makes a toxic sweat which can kill you straight away if you eat it. Well, it's the same with this animal. If you eat a rough-skinned newt that's not been prepared correctly, you can swallow their toxins and things get very bad. You can die almost straight away. Now, thankfully, it's a newt, it's got rough skin, looks a bit like a strange beast from a sci-fi movie. It doesn't look very appetising, and it's a rough-skinned newt. But then again, you're not a snake, who do like to eat them. Must look appetising for those, and it means it gets a place on our dangerous Dan list. Before we finish up this week, let's check in with Techno Mom. She is our gadget guru, our genius, who knows everything about why things work, how they were made, who made them, and how we use them every day. This week, Techno Mom is making us brighter by making things brighter.
Techno Mom Fast Files.
You probably know to turn lights off when you're not using them, or you should. But do you know how light bulbs actually work when you click the switch? Older types of bulbs send electricity through a thin wire, which glows when hot. This type of bulb doesn't last very long though, and can be fragile. The most common type of bulb these days are energy efficient ones, CFLs, or compact fluorescent lights. Electricity makes a gas inside give off light. They use a lot less energy and last much longer. LEDs are another type of lighting, made from tiny bulbs that are lined up in grids. You can see these on some torches, cycle lights, and even on some street and traffic lights, and in people's lights at home. Each LED is made to produce one colour of light when electricity passes through it. They use even less energy than CFLs and can last over 10 years. Why not check out the bulbs in your house? Are they energy efficient?
Techno Mom, with the Institution of Engineering and Technology, advancing and sharing knowledge.
And that is it for this week's Fun Kids Science Weekly. Thank you so much for listening. If there is anything science that you want answered on the podcast next week, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. While you're there, you can check in with loads of our brilliant podcast series. You've heard a few today. We've got tons more for you. You can also get them on the free Fun Kids app too, and wherever you get your shows. And Fun Kids, we are a children's radio station from the UK. Listen to us all around the country on the free Fun Kids app or at funkidslive.com. And if you've got a smart speaker, wake it up and ask it to play Fun Kids.